Algebra 2, here we go. We're back at it today with simplifying radical expressions. Now, we've done this a little bit before with maybe the fourth root of 32, x to the fifth, y to the seventh, etc., something like that. We're going to expand on that today, okay? We have a quiz coming up, so a couple review problems at the beginning to get you started here. You're going to do these by yourself, all right? First ones here are saying write each expression using rational exponents. Okay, so we want these with exponents. So go ahead and do the first one here, the fourth root of 97x. Rewrite that. Power over index, don't forget that poi. So we have that 4 swings around and it becomes the 1/4 power. Now here's the thing, that 97 and that x are inside the parentheses, so we have to group it together using, inside the radical, so we have to group it together using parentheses. You can also do 97 to the 1/4, x to the 1/4. Just remember that 1/4 power goes to the 97 as well. All right, let's try the second one here. It says rewrite using rational exponents and simplify if possible. That one's going to come into play here. All right, so go ahead and do the second one. All right, first step here, rewrite it using rational exponents, because that's going to help us combine these here. We have the same base, 6 and 6, so now we can use properties of exponents, okay? A couple things here. Whenever, if you just have a 6, the power is 1, okay? And when you don't have an index, it just means square root the index is 2, okay? Okay, at this point, I'm saying simplify because you're looking for same bases. We like that because we have a property that says, hey, if you're multiplying the same base, we're going to keep that base and we're going to add these exponents. So we have 1/2 plus 3/2, which is 6 to the 4/2. 4/2 is just 2, so we have 6 squared, which is just 36. All right, now that's where these properties come into play, because when we started with this problem here, there's no other way you can simplify this to get 36, right? We don't know the square root of 6, so there's nothing we can do but once we convert it to that other form. So that's kind of where those come in handy. All right, try these two. This is where we're going the other way. Write each in a radical form. So right now they have rational exponents. Rewrite in radical form and simplify if possible. Okay, and again, sometimes going to radical form helps us evaluate or simplify. So this first one, 16 to the 3/4. Go ahead and do that one. Okay, converting to radical form, we see it's just really the fourth root of 16 cubed. We can do those in any order. So first I took the fourth root of 16, which I break down. We have 4 2's, so it's just 2. And then we cube that, we get 8 as my answer, okay? So that's where going to radical form helps you evaluate. Second one here, try it out. All right, power over index. Are we going to swing that 5 around? Yes, we are, but here's the thing. That 4 is not included, right? That 4 really, because there's no parentheses, means just to the first power. So when we swing that index around, it's only with the x. So we have the 4 times the fifth root of x cubed, okay? So again, just be cognizant of what's grouped together. All right, that's some review. We have one more review. Stuff you'll see on the quiz, all right? So if you have any questions on this, make sure you're asking. Simplify. All right, this doesn't look simple at all. We want to make it look simple. It's not that bad. Try it out yourself. Okay, anytime you see the same base, we're going to use properties of exponents, okay? But also anytime you see a negative exponent, we're flipping it, doing handstands, moving it to the other side. So basically these y's are going to trade places here. On top we have the 2x squared y to the positive 6 now, and on the bottom we have x cubed, and then this y to the negative 4th becomes y to the positive 4. All right, we're going to use those properties where we keep the base. So we have x squared on top, x to the 3rd on the bottom. We keep the base and subtract the exponents, and then y to the 6 minus 4. If we do this, we get 2x to the negative 1 y squared, and again, negative exponent. Now this x is going to have to go to the bottom. So we have 2y squared, x to the negative first moves to the bottom and just becomes x to the positive first. Okay. Those are using the properties. At this step here, we could have also just gone and seen that we have, okay, we have one more x on the bottom. Whoops. We have one more x to the on the bottom. So this crosses out and this just becomes x to the first. And we have 2 more y's on top, so this just becomes y squared. So we'd get the same thing. That's one way how to use these properties here, or just kind of seeing, hey, where do we have more y's? How many more do we have? Okay, that's basically all we've done this unit so far. We're going to expand on it today, but you should be able to do those last couple no problem for the quiz and certainly for the test coming up. All right, we are simplifying radicals today. We've done this before. We're going to expand on it today. So rationalizing the denominator, here's the thing. We can't have radicals in the denominator. That's an irrational number. We have to rationalize it, okay? So no radicals in the denominator and no fractions under the radical, okay? So if you see either of those things, fix it, change it, okay? This first one here, 3 over the square root of 6. Now, previously we've done these, and we multiplied by square root of something over the square root of something to make sure we get rid of the 6 on the bottom. Okay. And you're right, we put the square root of 6 over the square root of 6. One more time, the reason we can multiply by this is because this just equals 1. You can multiply anything by 1, it doesn't change it. So we're okay there, we can do this, we're not getting in trouble with the math police. And if we do this, on top, we get 3 times the square root of 6. One is inside of a radical, one's outside, so we can't really combine those. On the bottom here, we get the square root of 6 times the square root of 6, which is the square root of 6 times 6. And this is just the square root of 36. And the square root of 36 is just 6. Okay, so when you've created a group of 2, actually, instead of square root of 36, I'm going to write it this way. 6 squared, right? What's the square root of 6 squared? Well, those kind of undo each other, right? Or power over index, square root of 6 squared is just 6 to the 2 over 2, which is just 6 to the 1, which is just 6. Okay, so on the bottom, we have just 6, all right? So anytime you have a group of 2, if you're taking the square root, you just get the number inside of there, or the value inside of there. All right, last step here, 3 and a 6, we can reduce that. 3 goes into 6. We have a 1 on top, 2 on the bottom. So we get the square root of 6 over 2. All right, same number, just no radical in the denominator. We can't reduce this because that 6, it's inside of a radical. The 2 is outside. All right, a little more difficult. We have the cube root now, index of 3 of 4 over x. Now, first thing we're going to do is we're going to separate these. Separate the top and the bottom. So we're going to give the top its own radical, the cube root of 4, and the bottom its own radical, cube root of x. Okay. Now, we're going to have to get rid of this cube root of x to rationalize the denominator. And we're going to certainly multiply by something over something. Now, we started with an index of 3, so we're going to multiply by the cube root over the cube root. Okay. Now, here's the thing. Where I'm highlighting, you see how when we had square root of 6, we multiplied by the square root of 6? Because then we created the square root of 6 squared. So that index matched the power or how many we're looking for. That's our goal over here, okay? Our index is 3. We're looking for 3 of a kind. Okay? I was playing cards this weekend, and we were playing rummy, and you had to get 4 of a kind for the certain hand I was playing. So think of it like this. Think of it as cards. We're looking for 3 of a kind, okay? 3 of the same number or variable. So we have 1x here. Okay, we have 1x. So we're looking for 3 of a kind. How many more x's do I need? That's right, I need 2 more x's. So I can write that as x times x, or I can write that as x squared. Okay? If that's on the bottom, we have to multiply by the same thing on top. Let's see what we get. On top, these are both in the radical. We can squish them inside the same radical. We get the cube root of 4x squared. On the bottom, take a look. When we multiply these together, we get the cube root of x times x squared. We have a property that says when you're multiplying these bases, you add the exponents. We get the cube root of x to the third. What's the cube root of x to the third? Well, we can either just cross out the index and the power, or if you convert it, you would have x to the 3 over 3, which is just x to the 1, which is just x. Okay, so I prefer to just cross out, okay, the cube root of x to the third is just x. So when you've created that group of 3 of a kind, one of them comes outside. So we're left with just an x on the bottom. All right, rationalize the denominator. They're kind of fun. It's like a little puzzle. It just takes a little practice. All right, a little harder. Again, I told you algebra 2, it's twice as much algebra as algebra 1. And here we go. Okay, we have a fourth root on the bottom, can't have it, so let's get rid of it, okay? We're gonna rationalize it by multiplying by, again, we have fourth root here, so we're gonna start by the multiplying by the fourth root over the fourth root. Now, whatever we do on the bottom, we're also gonna have to do on the top. Okay, we need 4 of a kind, we're looking for 4 of a kind of everything in this denominator. So we need 4 2's and 4 x's. Now, right now, I just have 1 2. So I'm gonna need 3 more. I'm gonna write that as 2 to the third. And I have 3 x's. I'm looking for 4 of a kind. I need 1 more x. And let's do the same thing on top. 2 to the third times x. Okay. For multiplication, we just multiply across the top and the bottom. We have outside of the radical, negative 2x to the third, and inside the radical, 2 to the third times x. On the bottom, let's kind of do it down here. We've created, inside the radical, let's squish these together. We have 2 to the first, 2 to the third, x to the third, x to the first, all right? You can see here, you don't have to do the step every time, that we've created 4 2's and 4 x's. Well, fourth root of 2 to the fourth is just 2. Fourth root of x to the fourth is just x. So on my bottom, I have 2x, okay? Now, are we done? No. We have same base on top and on the bottom, right? We have x to the third on top, x to the first on the bottom. If I notice, I have 2 more x's on top, so I can kind of cross that out and just write x squared. I also have a negative 2 on top, 2 on the bottom. I can cross that out and just write negative 1. So my answer is going to be, I have a negative 1 or just a negative x squared times the fourth root of 2 to the third. 2 times 2 times 2 is 8. Let's write 8, it's a little prettier, times x. Nothing on the denominator because it all canceled out, okay? A couple things when you're doing these, don't forget your index because that's important, right? My cat thinks so. That index is important because the fourth root is different than the square root, and I can't read your mind, so we need to make sure that we have fourth root down and not square root or something else, okay? All right, a little harder still. So we have a radical in the denominator. We need to get rid of it. Now remember, we're looking for groups of 3 of a kind, but you might notice I already have a to the third here. So instead of trying to create a group of 3 of a kind, we're always going to try and look and see where we can simplify the radical first to make our life a little easier. So if you remember simplifying radicals, basically let's take the cube root of 16a to the third b squared. Let's pull out anything we can before we start to multiply. So I'm looking for 3 of a kind, 16. Let's find those groups of 3, 4 and 4, 2, 2, 2, 2. So I can actually pull out 1, 2. So let's do that over here. I can pull out a 2, but then I have 1, 2 left inside. They don't have a group of 3. Okay. Now, a to the third, how many groups of 3 can I pull out? Just 1, a, and nothing's left inside. And then I also have that b squared, no groups of 3, so that can stay inside. Okay, so we've simplified the denominator. Let me go ahead and change this. All right, we're gonna put in that. All right, like magic, we have a new denominator. Same thing, we've just simplified it. Now, we can multiply by what we need to create those groups of 3 of a kind. All right, my index is 3, so I'm starting with the cube root. Okay, I have 1, 2. How many more do I need? 2 2's, so 2 squared. And I have 2 b's. How many more do I need to get that 3 of a kind? 1b. And then let's do the same thing on top. Let's put 4b. All right. On top, nothing outside of the radical can multiply with inside of the radical, so we're going to leave these separate. On the bottom, we've created groups of a 3 of a kind, but don't forget this 2a. It was already there. It's just still hanging out, okay? On the in the radicals, we've created the cube root of 2 to the third, b to the third, so we're just left with 2b. All right, It looks pretty good so far. The last thing though, I see A's and B's on top and the bottom. So we can reduce these, all right? I also have 2 times 2 on the bottom, which is 4, and a 4 on the top. So let's get rid of all those actually. All right, I have 8 A's on top, 1 A on the bottom, so I'm really left with 7 more A's on top, 6 B's on top, 1 B on the bottom, so I really have 5 more B's on top. Okay, so this one cleans up pretty nice. I'm left with A to the 7th, B to the 5th, times the cube root of 4B. Not bad, right? All right, let's try one more. All right, first things first, let's split this apart, right? So let's give the top its own radical and the bottom its own radical. Now here's the thing. It says simplify radical first. We can't really pull out any groups of 4 because 25 is just 5 and 5 and only 3 y's. But here's the thing. 25 has 2 5's. So let's start creating a group of 5's. This is kind of the trick with this one, and it's going to make our life a little easier. So we're going to rewrite this as the 4th root of 3x to the 3rd over the 4th root of 5 squared y to the 3rd. All right, now let's rationalize that denominator. We're going to multiply by 4th root over the 4th root. Don't forget that index. Okay, now we need groups of 4 of a kind, okay? We have 2 5's. So let's get 2 more, 5 squared, and let's do the same thing on top. And we have, in purple, 3 y's. We're going to need 1 more y to create those groups of 4 of a kind, okay? So here's what we're left with. We have on top, inside the radical, we can combine these inside the same radical. The 4th root of 3 times 5 squared times x to the 3rd times y. Okay, I just kind of reordered that as I wrote it. On the bottom, we've created groups of 4 5's, so we just left the 4th root of 5 to the 4th. 4th root of 5 to the 4th is 5. That's a tongue twister. And we've created 4 y's, so just y. Okay. On top, we just have a couple numbers we can multiply. We have the 4th root of 3 times 25 is 75. X to the 3rd y over 5y. Again, we can't reduce inside and outside of the radical like oil and water. Doesn't mix. Can't do anything else, okay? So that's it. That looks good to me. At the beginning, here's the thing. If you multiplied, if you had like the 4th root of 3x cubed over the 4th root of 25y to the 3rd, let's just say you created groups of 25, you would have 25 to the 3rd y. When you multiply on top, you're going to get a really big number. Let's see, 25 to the 3rd times 3. You would get the 4th root of 46875. You would have to find groups of 4 to bring out. So it's just easier the way we did it by creating, by rewriting 25 as 5 squared. You won't see that very often, but it's a nice little trick to help us get to the answer a little faster. All right, you finished another ed puzzle. Here's what we're going to do now. We have an exit ticket. I think Google Form will be in Google Classroom, and then you're going to start on the homework, okay? Use this time wisely. I get a lot of people emailing me later saying, couldn't finish the work. That's why I'm giving you plenty of time during class, all right? Work hard, finish it right now. That way you don't have to email me later, okay? Let me know if you have any questions. Exit ticket, start on the homework. Good luck. Bye.